Okay, we are given the graph of this ellipse, and we want to find the center. So for lack of a better word, let's talk about the diameter. So here is the widest part in this direction. Here is the widest part in that direction. So you'll see we have y equals 2 here. We have x equals -3 here. So the center is -3, 2. Now, what does that tell me? Well, remember, our general formula for an ellipse will be x minus h squared over something plus y minus k squared over something equals 1, a squared, b squared, depending on which one is bigger. So x minus -3, this will become x plus 3 squared over something plus y minus 2 squared over something is going to equal 1. And then we'll work on filling in those somethings. Now, what about our vertices and our minor axis? Well, the vertices are along the major axis. So we have a vertex at 3, 2 and a vertex at 3, -9. So what does that tell me? Vertex 3, 2, remember this is as far as you can go on the major axis, 3 on x, 2 on y. And -9 on x, 2 on y. That's what I should have said. Let's scratch that. So 3 on x, 2 on y is one vertex, -9 on x, 2 on y is the other vertex. So we have those values. Now we need to see what is the span. My center was -3, 2. To get from -3, 2 to 3, 2, how far did I go over in the x direction? To get from -3, 2 to -9, 2, how far over did I go in the x direction? So let's take a look at that again. So remember our center here is -3, 2. Let's count to get to the end of the major axis to a vertex. 1, 2, 3, 4, 5, 6 in that direction. Count in the other direction, 1, 2, 3, 4, 5, 6. So therefore my span in the x direction is 6. So what is that going to tell me? In the x direction, it's going to be 6 squared here. So we have our vertices. We also need to get our points on the minor axis, and how is that going to enable us to determine this denominator? What are the endpoints on the minor axis? Let's go back and look at our graph. We have a point here, which is -3, 7, and a point here, which is -3, -3. -3, 7, -3, -3. So let's think about that before we actually count. I'm getting from -3, 2 to -3, 7. How far up am I going in the y direction? I'm assuming that's up 5. -3, 2 to -3, -3. 2 to -3 is down 5. So the span in the y direction sure seems to be 5. And we'll clarify that by counting. So here is our center. Count 1, 2, 3, 4, 5. Great. Count 1, 2, 3, 4, 5. So our span in the y direction is 5. So I need to have 5 in the denominator of my equation. So that will be there. Now regarding our length of our major axis and our length of our minor axis, fine, we have the two vertices, we have the two endpoints. The length of the major axis. The span was 6, so the length should be 12. We can count it if we like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Length of major axis is 12. Length of minor axis, again, count it 1, 2, from here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Length of minor is 10. So we have our equation. We have our lengths. Length of major is 12, length of minor is 10. We have our vertices, we have our endpoints on our minor axis, and we have our equation. So the last thing we need to get is we need to get our focus. So we'll simplify our equation just a little bit. X plus 3 squared over 36 plus y minus 2 squared over 25 equals 1. To help us find the foci of an ellipse, we use the equation c squared is the larger of those minus the smaller, a squared minus b squared. So what I'm going to have here is c squared is 36 minus 25. What is that? 36 minus 25 is 11. So c squared is 11, which tells me that c is plus or minus the square root of 11. So where does that put the two foci relative to our center? Remember, our center was negative 3, 2. Our center is negative 3, 2. The foci are on the major axis. So we have to go in the x direction, root 11. In the x direction, root 11 this way. In the x direction, root 11 that way. So negative 3 plus root 11, negative 3 minus root 11 will give us our x values. And then the y value stays the same, stays 2. So where are our foci going to be? What are we going to say? Again, center is negative 3, 2. We're going root 11 in the x direction to get the two foci. So negative 3 plus root 11 goes to the right, comma 2, and negative 3 minus root 11, comma 2. So let's just visualize that if we can. Let me go to Desmos and we'll quickly graph this. And we'll see if it looks like what we had before. I hope it does. So we're going to graph x plus 3 squared over 36. Plus y minus 2 squared over 25. Equals 1. So that should look like what we saw on the other page. And we believe the foci are at negative 3 plus root 11, comma 2. You see that point on the major axis, and negative 3 minus root 11, 2. There's the other point on the major axis. So the distance, if we pick any point on here, the sum of distances from here to here plus from here to here should be the same as from here to here plus here to here should be from here to here plus from here to there, etc. That's what an ellipse is. The sum of the distances are constant.